Good evening, everyone. My name is Atul Dev. I'm a director in the machine learning team at AWS. And today, I'm here to talk about the future of software development powered by machine learning. Let's get straight into it. So this is the typical journey of a developer, right? It involves a few stages. People write code, there's code reviews, security and ops review, and mitigation of issues. Now, let's talk about use of machine learning for software development, right? So we embarked on the journey to use machine learning to improve the productivity of developers back in 2019 with the launch of CodeGuru, Amazon CodeGuru. There are two core features that CodeGuru provides developers. The first one is code reviews to detect any critical security issues or other flaws in your code. The second one is CodeGuru Profiler. CodeGuru Profiler helps you detect the most expensive lines in your code. In addition, we also launched Amazon DevOps Guru in 2020. Amazon DevOps Guru helps you identify any issues that might indicate that your application health is not trending in the right direction. It ingests data from all different logs, including CloudWatch logs, CloudTrail, and helps you understand if there are particular metrics like latency that are not heading in the right direction and what you should do to fix them. Now, we come to code writing. Now, here, this morning, Swami announced CodeWhisperer. CodeWhisperer is our offering which generates code for developers in their IDE based on their context. Now, you would say, hey, code completion has been around for a long time. What's so special about code completion in 2022? In the past, code completion has been for a single line, right? IntelliSense or some of these other code completion tools that you may have used in the past basically help you get to the next kind of one word. You could basically get the properties of an object, or it helps you get kind of the parameters of a function. Whereas with CodeWhisperer, you actually can get multiple lines of code recommendation as you're typing based on the context of what you have written so far. It also generates code from plain English comments. I could literally just say the task that I want to accomplish in plain English, and you get several recommendations that you can choose from. And as the last point, it is available in all major IDEs as an extension. It's part of AWS Toolkit. So today, the languages that it supports includes Python, Java, and JavaScript. We are going to offer support for C# and TypeScript in the coming months. In terms of IDEs, we support the JetBrains family of IDEs, which includes IntelliJ, PyCharm, and WebStorm. We also support VS Code and the Amazon or the AWS IDE, which is Cloud9. Additionally, you can also use CodeWhisperer in the AWS Lambda console. Again, I don't know how many of you have used AWS Lambda console, but in the console itself, you can write small snippets of code to test out your Lambda functions. Because of this built-in functionality, you don't have to go anywhere. You can just be productive right in the Lambda console. We'll also add support for Visual Studio in the coming months. And last but not the least, while CodeWhisperer is meant for general purpose software development, it is also exceedingly good for AWS APIs. So any code related to AWS APIs, it will do a good job. Now, AI has become very prevalent in the last few years. But as the saying goes, the power of AI comes with responsibility. You may have seen some of these comments in the past few months around use of machine learning for software development. With CodeWhisperer, we offer three main features around this aspect. The first one is security scan. CodeWhisperer provides built-in security scanning as part of the product, which you can use for not just the code generated by CodeWhisperer, but also the code written by you in your IDE. It also comes with a built-in reference tracker. Now again, this CodeWhisperer has been trained based on billions of lines of open source code and also Amazon.com code. However, the models most often generate code that is completely unique, but there are situations where the code may have similarities with the code that was used for training. In such situations, the reference tracker will flag that particular code and give you a chance to basically make sure that you can make a decision whether to include that generated code or make necessary attributions. It also has built-in capabilities to avoid bias. It'll prevent generation of code that may have aspects of bias to it. Now let's talk about some customer and partner codes. We have 2 codes from SmugMug and Finra here. We also have JetBrains. As we discussed earlier, CodeWhisperer has a plugin for JetBrains IDEs. Next, let's do a quick demo. So I'm in PyCharm, and I'm just going to write out a simple comment, convert. It's back? Okay. Convert a JSON file. Oh, cool. It already knows what I want. I hit enter, and then it gives me the signature. I say OK. And now it's generating the code, and as you can see, it's given me 3 options to choose from. I simply use my arrow keys, and I see a few different options. I'm going to pick one right now, and I hit enter. So, and then now it's giving me the reverse of it, actually. I said convert a JSON to a CSV, and it actually tried to give me the next one. So I'm going to say tab and keep going. So that's an example of general purpose code generation where AWS APIs are not involved. Now let's also take an example of code generation based on AWS APIs. Okay. All right. And as you can see, there are 4 recommendations that have come up. I can quickly cycle through these recommendations, see which one makes most sense, and accept. I'm just going to pick one right for now. Oh, now it's saying, it's giving me an option to download a file from S3. I think, again, I'm going to tab it just for now, and I'm going to stop it. I think you guys get the idea that it is trying to understand the context of prior code and figure out kind of what you should be doing next. So I'm going to stop this demo and hand over to Patty now, who's going to walk you guys through the internals of how we build this service from scratch. Thanks, Patty.
Hey everyone, I'm Parminder Bhatia, Applied Science Manager in AWS AI Labs, and today we'll be talking about the technology, underneath technology that was required to build CodeWhisperer. So one of the first concepts that we'll talk about here is about the upcoming field of what's called as programming language processing, which is basically a combination of machine learning and programming analysis and synthesis. This basically PLP basically consists of 2 major categories. The first one is around source code understanding tasks, and the second one is around source code generation tasks. So what I mean by source code understanding tasks, such as bug detection or code repair, which helps you to understand the syntax of the language, along with control dependency as well as data dependency. And then there are other sets of tasks. For example, source code generation tasks, like the generation examples we saw over here, code summarization, etc., that goes into the semantics as well as syntax of the language to provide the correct responses. So the motivation when we were building CodeWhisperer was to incorporate both the syntax as well as the semantics of the source code of the language into vector representations by utilizing huge amounts of unlabeled data via language modeling. Next, we'll talk about language models. So there's a huge search about language models and how you can train these massive models. So first, we'll talk about different types of language models and their potential applications and use cases where they are particularly useful. The first one is what's called as autoregressive decoder or left-to-right decoder, where the idea is that the model is trained from left to right. Some of the categories that belong to this one are GPT-style models. So the idea over here is how we can train these models using the data going from left to right. Particular use case for these kind of models is in the case of code completion, as we saw. So given a developer who's writing a code, and we can provide the remaining part of the code. So as you can see, the input as well as the output is more in the case of completion, and they can belong to same type of modalities where input is also code and output is also code. The second style of model, which is called as sequence to sequence or encoder decoder kind of model, which consists of encoder which is bidirectional. And what do we mean by bidirectional is that when we are trying to do predictions, a particular token can look at the things from the left as well as from the right. So it is also called as full attention. Whereas the decoder is, again, autoregressive model or causation model or left to right model, where the idea is you would go from left to right. Now, this is particularly useful when you can have data in different modalities. For instance, if someone says, get my data from S3 and run sentiment analysis. So over here, the input modality is the text, and the output that we're trying to generate is the code. So these are, both of them have their own advantages and use cases. And when we are trying to build CodeWhisperer, we want to take advantages of both the systems. And one kind of technology that becomes particularly useful, which does a combination of the two, is kind of going towards prefix LM, which is basically a multitask between this full attention BERT style model along with GPT style model, which is kind of autoregressive. So we talked about these different family of language models. So recently we have seen BERT style or GPT style models have been applied for a variety of different applications. And they have worked quite well on a variety of different tasks that we just saw recently related to even code understanding and generation related tasks. However, they are still suboptimal because they do not use the full context that is required and that is particular for a programming language. For instance, they might not understand the syntax in a way, or what does that semantics mean if we just consider them as an input-output of the model. So this makes it particularly important to incorporate this information when we are trying to train these models. So in the previous slide, we saw two categories of model, where the BERT style model is what uses this mass token recovery, where the idea is you would denoise some of the tokens over here and try to generate that. So this is the idea of the first one that you would see in all the current models. What is mainly novel over here is the last category over here, which is what you can see we are actually using the programming language syntax as well. So what we are doing over here is we are actually masking or deleting the identifiers for a language, and then we are asking the model to predict those. So if you can see in the third corrupted example, you have a lot of mass which were actually required for max operators or variables that should be incorporated in the function, and we are trying to predict those. And the whole idea over here is that this can help us understand the syntax and semantics of the programming language conveyed from the developer assigned identifiers. So we looked into different parts of language models and large language models. But one of the key components over here is actually the data, and actually huge amounts of data, which is of high quality. So high quality data is quite fundamental to the success of CodeWhisperer as well. So to achieve this, we actually have built a pipeline which can ingest of data from multiple sources in a scalable and a clean manner. So once the data has been ingested, the second phase that comes over here is what's called as data analysis. So similar to the technologies that we show to the customer, we apply those even when we are trying to select the data. So that goes into, for example, applying tests related to vulnerability. Does the code have security flaws or not? Looks into the license attribution, trying to redact the PII from the data, as well as looking into the syntax that can be found in the data. So the idea is, after applying these different data analysis and filters, the quality of the data that you get is quite high. Next, once this data has been selected, we again do further rounds of filtering, tokenization, formatting, chunking, and sampling, which helps us to create a really high quality training and evaluation set. A key component over here, which also needs to have some emphasis, is around the step of duplication and deduplication. So as you can see, a particular code would have at least 8 to 10 copies in the file. So whereas it's really important to A, take the data which is of higher quality, and B, to reduce the noise, because it's possible you might train on things which will be a duplicate of each other. So deduplication becomes quite critical for training these large models as well. So one of the trends that we can see in these slides, so we wanted to see how these models perform as we scale them. So over here we can see when the evaluations that we applied on 2 diverse data sets, looking into completely different use cases, that as we scale the model, going from millions to billions and billions of parameters, we observe that the accuracy, robustness, expressibility, and generalization of these models also consistently improves as the scale goes to billions of parameters. Now, the best scenario is we keep scaling these models forever and use them. However, they do come with one caveat. So in order to improve the actual developer experience, you want to be able to do inference on these models. So most of the models that we are talking about might not even fit in the largest GPUs in the world. The other thing is, as they scale, the inference time will also become so significantly high that the actual gain that you might get from these systems might become quite minimal. So this motivated us to move into the direction of applying different efficient model compression techniques that we'll briefly discuss over here. So a couple of techniques that become really predominantly used in these model compression techniques are distillation and quantization. So to briefly explain distillation, distillation is a process where you have a small model which is called as a student model, and that model tries to mimic the behavior of a very large model, which is a teacher model. So the idea is that even with the smaller model, by mimicking the behavior of the large model, it can gain the gap or reduce its performance from the large model. The second concept, which is that of quantization, which is basically a process of mapping high precision, where most of these models would be stored in 32 bits or 16 bits to lower number of bits, which might be 8 or less, which has the advantage of memory footprint and also improving the inference time or latency of these models. So as part of the research that we did, which was actually published at ACL 2022, we actually used a technique which is called as distillation-aware quantization. Over here, we basically combined the two concepts together in a meaningful way. And this was applied on a variety of different generative tasks. And what we observed was that we were able to reduce the model size by about 16 times by applying this strategy, and we're able to get pretty good results on tasks related to summarization, question answering, and a variety of different problems. So that was the main motivation of moving in this direction. However, even after applying this, we could still or we cannot still fit the model into a single GPU. And that shows this, the scale of the models that we are talking about over here. So then the next set of strategies become equally critical, which is called as model parallelism or tensor parallelism, where the idea is you would split a massive model into multiple GPUs, and then you would do inference on them in parallel. This has a couple of advantages. First, you can actually host these massive models now. That becomes a reality. And secondly, because you're doing inference on them in parallel, you can actually improve your overall latency. So your latency will be the artifact of the largest model that you can fit into a GPU. So by applying all these strategies, we were actually able to reduce the timing to actually generate response to near real time, as we saw in the demos, thereby improving customer experience. Next, I'll hand it over to Atul, who will just wrap up the conversations.
Thanks, Harry, for explaining the details of how CodeWhisperer works. So one of the things that I forgot to mention was, in addition to giving you code based on the context in your natural language comments, CodeWhisperer also gives you unit test code. So you can simply just say test underscore name of the function, and CodeWhisperer can generate the corresponding unit test for you. I'm sure most of you don't enjoy writing unit test code. So CodeWhisperer is now in preview, and you can use this link to provide basic details. And as soon as you get the access, you should receive an email with a token that you can use in the IDE of your choice, and you should be able to start using CodeWhisperer after that. Thanks for your time today. Hopefully this was helpful for you guys. Thanks.